large enough to handle 250,000 users, or do we make sure that we know every single operator? And I don't know the right answer for that. People periodically come up to me and say, do you think that all the servers out there are just running it to catch whoever's using it? I don't think so. I mean, we've got 2,000 servers, and probably nearly all of them are nice people who really want to donate their traffic and donate their bandwidth to help out with making users able to be anonymous on the internet. And there are probably a few bad ones. So one of the ongoing research questions is, how do you tolerate a few bad nodes? Because if there's only one, then they're never going to learn that Alice is talking to Bob. And if there are, 5 or 10 out of 2,000, your odds are still pretty good. So that's still something we need to think about harder. Another exciting point. We'd really like to get some sort of general sense of how many people are using Tor and what countries they're coming from, stuff like that. So that we know what we should focus on, what features we should work on, what translations we should make sure we have next in Vidalia and Torbot and stuff like that. On the other hand, it's an anonymity network, so we don't really want to know how many users are using Tor and where they're coming from and stuff like that. So there's definitely a tension there. Right now, if you run a directory mirror, then you can watch all the different users connect to you, and you can get some sense of who's using Tor. Again, you're not learning that Alice is talking to Bob, you're just getting a list of the different Alices out there. And we'd like to fix that at some point. The next step is similar to the entry guards, where you pick 3 or 4 nodes and you always start at them. We should pick 3 or 4 directory caches and you always use them. And that means that there isn't any place you can go to enumerate a set of who's using Tor right now. On the other hand, we still want to be able to collect some aggregate data about how many users there are and what countries they're coming from. So one approach might be that we could start having every relay make a little anonymized summary of the past day, where you say, well, give or take 10%, I saw 100 users from the US and 70 users from Germany and 200 users from China. And if we can do that in a way that you can add them up and get a useful number without aiding traffic analysis, then we'd be in good shape. So another thing that we'd like to solve. Okay, other fun stuff. Turns out there are some jerks on the internet. Turns out that some of them use Tor. And that means that certain services out there that can't do authentication end up blocking all of Tor. For example, Slashdot does not let you post through Tor, because some jerk said Slashdot sucks enough times through Tor. Wikipedia does not let you edit through Tor, because some jerk wrote Wikipedia sucks on enough different pages through Tor. And a bunch of IRC networks don't let you show up through Tor, because there are enough trolls and jerks on IRC already that they couldn't handle even more. So there are a couple of success stories. For some of the IRC networks out there, like Freenode, they were having problems with people showing up through Tor, and they had a lot of different connections, and suddenly there were like 30 people in one channel coming through Tor, and then they all started yelling at each other, and mass chaos ensued, and they had to shut down the channel. And that was no good, because Tor was basically DOSing their communications. So originally they said, okay, well, we're going to figure out all the Tor servers, and we're going to block connections from those. But soon after, they realized all we really need to do is figure out the Tor users and label them as Tor users. So now when somebody shows up to Freenode using Tor, it says, a Tor user has shown up. We don't know which one because it's anonymous, but this guy's coming from Tor. So that means that when 30 people try to subtly join your channel, all coming from Tor, then you say, a Tor user, and another one, and a third one, and a fourth one. Hey, I'm about to be attacked. So this means that the jerks who were doing that went back to using open proxies and bot networks and whatever they were using before. They stopped using Tor because it wasn't the best way to attack. So you don't have to perfectly lock out all abuse. You just have to make sure that you're not the easiest avenue for abuse. So that's one success story. There are a couple of other things to think about on this topic. For example, there are a lot of network and sysadmins out there who think that Tor couldn't possibly have very many users. They figure that there are 6 people somewhere in the world using Tor, and they see one jerk show up through Tor. So then they say, one of your 6 users is an idiot. Tor is stupid. And it's hard to explain this to them because they don't realize that we've got 250,000 people just using Tor for normal internet hygiene, so they can go to Amazon and not have Amazon build big databases about them and all the other reasons that people use Tor. So there's an easy fallacy to fall into where you figure that Tor has no users and therefore you see one bad case and you figure that all Tor users are bad. Because if Tor is working, you don't see anything. If people are anonymous, then you don't know about them. And then the flip side of that, right now Wikipedia blocks thousands and thousands, I think it might even be millions of IP addresses, because they are constantly in a hunt to find every possible bad IP address on the internet. And it turns out there are a lot of bad IP addresses on the internet because every Windows XP computer is quite likely to be a bad IP address over the course of its life. So that means Wikipedia is in a constant battle with AOL users and open proxies and Tor and universities and dynamic IP addresses and everything like that. Okay, so there are a couple of fixes we might think about. One of them is, wouldn't it be nice if Wikipedia would allow Tor users to connect, but it should treat them differently, like the Freenode IRC case. Right now, Wikipedia doesn't want to introduce any barriers to contributors. It doesn't want to make you log into an account. It doesn't want to make you do anything. You should just be able to show up and edit. But at the same time, they block hundreds of thousands of IP addresses. So how can we balance that somehow? One of them would be, if it's an IP that you trust right now, then you should just let it in. Let it do whatever you normally do. But if it's one that you would normally block, you should put some speed bumps there. You should make them solve 7 CAPTCHAs in a row if you really hate that IP address. And that means that they can still do it if they care, but you're slowing down the jerks enough that they'll go somewhere else. Another approach might be you should make them log in, and then they'll have an account. And if the account doesn't have any history of editing well, then the edits that they make should go into some place that has to be manually checked. And if they've done 3 good edits, then you whitelist the account, and then they can edit from any IP address, even the one that happens to have a jerk living next door, because this account is useful, even though the IP address is a little bit sketchy. So that would hopefully be enough to send the abusers back to using their AOL or their open proxies or whatever they're using right now. And if that doesn't work, there are some other approaches that don't have to change Wikipedia as much at all. There's a system out there called NIM, written by Jason Holt, who is now at Google, I think, and another one called Nimble, written by some researchers at Dartmouth. And the idea is that so there's a multi-phase registration process where at the first part you say, this is my scarce resource, and it's mine and not very many people have it. For example, this is my IP address, or this is my $10 bill, or whatever sort of scarce resource you have in mind. And at that point, you get a token that you get to use to log into Wikipedia or log into Slashdot or something. And as soon as Wikipedia says, that token abused me, I don't want to hear from it again, then you can blacklist the token without ever needing to learn the IP address associated with it. So you can make sure you never hear from that guy again, but there's no way to learn who he was. So these are some neat new designs, and we're hopefully going to try to build a few of them. And this means that we can build all this token stuff separately from the service, which means that you can have basically accounts that you make, so Wikipedia doesn't have to make accounts, and tokens that you make, so Slashdot doesn't have to enforce all of this. And this means that there's some centralized place where we make Tor compatible with these services without having to force every single service to change. And there are a couple of other things we've been doing to make this easier. One of them, if you go to exitlist.torproject.org, you can fetch some software or do some DNS blacklist style queries where you say, this is my IP address and my port, and that's the IP address I'm curious about. Is that a Tor exit node? And that means that you can very easily, using a DNS style interface, check to see if it's a Tor user showing up or not. And hopefully that will make people more amenable to doing something more than just blocking it, because they can easily check and then they should treat them differently however makes sense for them. And I should notice that blocking connections from the Tor network to your service is different from blocking connections from your citizens in Iran to the Tor network. We really, really object to the idea of some government or country or company blocking connections from their people to the Tor network. But we're more amenable to the idea of some service like Wikipedia saying, I'm sorry, we haven't thought much about authentication. The only option we've got for now is to block Tor, but we'll work on it. So we're happy to let them block Tor for a little while they figure out how to solve it and while we help them figure out how to solve it. So those are two different things. Okay, so those are policy, law, censorship. Couple things that we'd like to do in the future. Relay by default, we're getting closer. I had a slide earlier in the talk about how do we rate limit differently, how do we do relayed connections, how do we automatically detect IP addresses. All of that's in place. There are a few more things we need to do. One of them is it would be really great if one of the programs associated with Tor learned how to do a UPnP. So that means you can talk to the wireless router you've got and say, hey, can you open up a port and port forward it here? And that means that we don't have to say, step 4, go find the instructions for your wireless router and go figure out how to port forward, because users are never going to do that. Another approach, we need to somehow auto rate limit, because if you're on a cable modem or another asymmetric connection and you just let Tor go, then it'll fill up your pipe. And since you've got a small outbound pipe, you're going to end up dropping all your packets, even the non-Tor ones. So we really need to help people rate limit to a little bit less than the total bandwidth that they have available. And then the big question, how do we scale the network? So as the number of servers grows, the size of the directory consensus and the amount of descriptors you need to get is just going to keep on scaling up. And if we have users on modems in Iran or something like that, then we really can't have 10,000 users and say, well, before you use Tor, spend 3 hours downloading the directory information. And once you've done that, it'll be out of date. So spend another 3 hours downloading the new directory information. That can't work. And another approach is, and another issue is, as we have 10,000 servers, if we let every server connect to every other server, then we're going to have 10,000 TCP sockets open on each one of these. And Linux and BSD can handle this, but the default limit is 1024. And that means that we're going to have step 4, go figure out what a ulimit is and go change it. And that trick doesn't work for ordinary users either. So we need some sort of way to scale the network in terms of giving people information about what the topology is, and in terms of having a topology that doesn't have every single server connect to every single server. And then the last issue before everybody a relay, turns out that Windows networking is unlike every other OS we have ever heard of. And Tor servers don't work very well on Windows still. Because they don't do poll and select and stuff like that. I mean, they support it, but if you use them much, then Windows crashes. So right now we're in the state where we try to use them a lot, and then Windows crashes, and then users say, well, Tor broke my computer, and we say, well, you're running Windows. And I'd like to have a better answer than that. So we're working on all of these, and hopefully we'll get through a lot of them in 2008. Another thing to think about, incentives to relay. Wouldn't it be nice if we could give people better performance if they are a relay? Now, we need to be careful here, because the naive ways of doing this, the BitTorrent style tit for tat, I use your computer for a while, therefore you can use mine, is really scary. Because if I use your connection a lot, and then you want a fast connection, you say, who owes me a favor? Oh, Roger owes me a favor. I'll start my circuit through him. I just bought the ability to watch the first half of your circuit. So that's an easy avenue for an attacker. We'd rather have some design where it's not quite that simple. So one approach that we've been trying to simulate recently and is looking pretty good, the directory authorities should make test circuits through all the different relays to audit them, to make sure that they're actually up and actually providing about the bandwidth that we think they are. And if you're a well-behaving relay, we should put a little gold star by you in the network consensus. And everybody who has a gold star gets better performance. All the other relays look at that and they say, oh, you're a well-behaving relay, I'm going to give you a priority. So this means that if you want your Tor connection to be faster, you should click the darn button that turns you into a Tor server. And then over time, people will recognize that you're better and you'll get priority. So people who click the button will benefit because they'll be getting better service. But from an economics perspective, even the people who don't click the button should benefit. Because if enough people do click the button, then the capacity grows enough that there's even more capacity for the users who don't click the button. That's the good case. The bad case is that it all falls apart. So we're still pondering that a little bit before we actually want to deploy that on the real Tor network. Okay, another thing, there's a fellow at University of Waterloo in Canada named Ian Goldberg who's thinking about UDP transport. Right now, Tor transports only TCP, which means that it's got